Hello everyone, hope you are doing well. So this is our second part of video of disaster management and disaster. So till now we have covered the basic of disaster management. In this we done with the disaster definition, then some key terms related to disaster. Then we had done the DM cycle. After that, the institutional measures and framework of disaster management in India. Also, we had done the institutional framework of disaster management of world at the global level and briefly discussed the NDMA 2019. What are the pillars, what are the measures, and then we also done with the Sendai framework. What are the 7 global targets of Sendai framework? After that we had done with the specific disasters, both with the GS1 perspective and GS3 perspective. Means we also done the geographical phenomena of each disaster, the causes of each disaster, impact, mitigation, and NDMA guidelines. I also told you about how to generate points on NDMA guidelines and mitigation strategy. So we had done with the earthquake. So we had done earthquake, done with landslide, done with floods, then urban floods also droughts. So these all disaster and DM basis we cover in our previous lecture, that is part 1 of disaster management. So today in this lecture I will cover the rest remaining disasters, that was Tsunami, Cyclone, Cloudburst, heat wave, marine heat wave, biological disaster, industrial disaster, and the crowd management also. So let's begin with our lecture. So first is tsunami. So what is tsunami? Tsunami is a waves. So they are the ocean waves. So they are the huge ocean waves generate due to displacement of large oceanic water. So these are the huge oceanic waves which generate from the displacement of huge oceanic water. And why this displacement is happen? This displacement of water is due to the seismic activities in ocean bed, ocean seabed, then the volcanic activities, landslide in the ocean, melting of glacier if the huge mass of water fell into ocean. Then also, so all these activities, seismic activity, volcanism, landslide, release huge amount of energy which displace the huge column of water in the ocean, and these displacement cause the waves or harbor waves, because tsunami is a Japanese word. So it is a Japanese word which su means harbor and nami means waves. So they are the harbor waves, they are the huge oceanic waves generated due to the large displacement of oceanic water due to this seismic activity, volcanism, landslide in the ocean bed. So this is the tsunami. Now what is the wave? Let's understand the basic of tsunami. Then how tsunami is there. How tsunami formed. So first is waves. One is normal waves and here is tsunami waves. So how these waves are different? First, if you see a wave, so this is the crust, this is trough. So the basic concept, any wave have wavelength. Second, any wave has its speed. And third is amplitude. So any wave has its amplitude. So what is this term? Wavelength, speed and amplitude. So first, wavelength. What is wavelength? What is wavelength of a wave? So suppose this is a wave and this is a crust, this is trough, this is next crust. So the distance between the two crust or the distance between the two trough is known as the wavelength of that wave. Wavelength of that wave. So what is wavelength? The distance between the two crust or the distance between the two trough is known as the wavelength. Now talking about the speed, so you know what is the speed of the wave. Then there is the amplitude. Now what is the amplitude? Second thing is amplitude. Suppose this is a wave and this is the normal level. So the distance from the normal level to the top of the crust or distance from the normal level to the bottom of the trough is known as the amplitude of that wave. So the distance, if this is normal level, so the distance, this distance is known as the amplitude of the wave or this distance. So hope this clear what is wavelength and what is the amplitude of any wave. Now normal wave and tsunami waves. So how these two waves are different from each other. So the first reason is the normal wave. Suppose this is the ocean and this is the normal wave. So they are because of the wind. So these waves are generated from the action of wind. But what happen in the tsunami waves? These waves are generated from the oceanic displacement of water. Oceanic displacement of water in seabed. So these tsunami waves are due to the displacement of water in the ocean, and these normal waves in the ocean is due to the wind. Now the second difference is amplitude. So suppose this is a normal wave and this is the, let's suppose A is the amplitude of this wave. But what happened in the tsunami waves? The amplitude of this tsunami wave is very less. So amplitude of tsunami wave is less in the ocean. Why this amplitude is less? So first we'll talk about, that is third point. Third point is wavelength. So what happened in the tsunami waves? Tsunami waves, the wavelength of tsunami wave is very high, very large. So the distance between the crust, the distance between the two crusts is very large, around 100 to 150 kilometers. So what happened in the large ocean? If this is the ocean, suppose this is a ocean bed. So what happened? This displacement of water is due to some seismic activity or a volcanic activity in the seabed. Suppose here is earthquake. So what happened? Due to this seismic activity or due to this earthquake, the energy start releasing in the huge amount in the ocean. So due to this energy, what happened? The water above this is start to displace. So the column of water is start to displaced in the ocean, and due to this displacement of water, they generate a wave in the ocean. So this wave has very large wavelength, around 100 to 150 kilometer. So in the ocean, in a huge amount of water, these waves are not seen by the naked eyes because the wavelength is very high. So this wavelength is very high. Second, due to this wavelength, this 100 or 150 kilometer of wavelength, the amplitude in the ocean is less. So the second point is tsunami wave has large wavelength and less amplitude. Now see, this is the ocean and this is the land. So this is the continent, here is the ocean and this is continental shelf. So what happened? Suppose here the earthquake is there. Earthquake or volcanic activity is there. So due to this seismic activity or volcanism in the oceanic bed, what happened? The energy start releasing. So the water above this fold is start to displace in the huge ocean and which generate a tsunami wave. Now what happened? Due to this distance, so what happened? Here the distance between the surface of ocean and the bed of ocean, suppose there the distance is 1000 of kilometer. I am supposing this. Let's take an example that the distance between the surface of ocean and where the energy start is, let's 100 kilometer. Now what happened when this displacement, when the huge water came along the land, then what happened? The distance between, due to this continental shelf, the distance started decreasing. So here if suppose distance is 1000 kilometer, then here is 600 kilometer, here is 400 kilometer, here is 300 kilometer. Then what happened? The amplitude, so this water, where this water is gone, so but due to this what happened? The amplitude started increasing when this displacement, when this wave came towards the land or towards the coastal area. So earlier the amplitude is very less. So in the ocean the waves are not as much high. But what happened, as this water moves towards the land, moves towards the coastal area, what happened, the amplitude start rising. So it start rising, and the wave look more high. So what happened, due to this, there is a tsunami in the coastal area. In the coastal area. So here the more amount of water, that will inundation of water is happening in the coastal area. So this is the geography behind how tsunami formed. See, here. So along the fault there is a earthquake, there is a release of energy. So due to that, there is a displacement of water. Earlier what happened, the amplitude of any wave is very less, so they are very less wave with the less amplitude. But what happened, as the water moved towards the land, the amplitude of wave start rising, because the distance between the surface between the surface and the continental shelf is decreasing when the wave move towards the coastal area or towards the land. So here is one more diagram. So first, here the release of energy due to seismic activity or volcanism. Then the water start displaced. And what is the next step? There is a very small amplitude of wave. So the in the ocean, they are not seen as much high. And what happened, when they reach towards the land, towards the coastal area, the amplitude start rising, and which will impact the coastal area, which will increase the coastal vulnerability. So this is the process of tsunami. Now what is the India vulnerability towards the tsunami? So if you see, from this process only, you know that the coastal area is more impacted or more vulnerable to tsunami. So here our coastal area is more vulnerable towards the tsunami, or our island nations is also vulnerable to tsunami. So this data you can use, that nearly 7,500 kilometer long coastline along to 5,700 kilometer is prone to cyclone and tsunami. So out of 7,500 kilometer of coastline, 5,700 kilometer coastline is prone to tsunami. Now think about that, what are the causes of this tsunami. So I told you what are the causes. First is earthquake, seismic activities. So first cause is seismic activities, that due to earthquake, what happened, there is a displacement of water. Then there is a volcanic eruption in the seabed, or the landslide, it can be the one cause. And then the meteoroid impact also. So this is a rare if any meteoroid. So any meteorite, large meteorite hitting the ocean can generate mega tsunami also. So there are anthropogenic cause also, that is melting of glacier also. What happened, due to this melting of glacier, So due to this melting of glacier, large amount of water came in ocean, which also impact the tsunami, which also displaced the water. So these can be the cause, or one, climate change is also one of the cause. Due to climate change, the frequency, the intensity of this tsunami wave is increasing. So if the question came on the causes of tsunami, so you can write about these causes. Now this tsunami topic is so much relevant for UPSC exam this year, because what happened, 2004 there was tsunami in Indian Ocean. And due to that, 4 lakh people were dead due to this tsunami. So in December 2024, there is completion of 20 year of this, 20 year of 2004 tsunami. First reason. Second reason is there is an earthquake in Kamchatka Peninsula. So what happened? So there is an earthquake in Kamchatka Peninsula. So if you know the graph of world, map of world. So here so I'm roughly draw this map of world. So what happened here at Kamchatka Peninsula, there is a huge earthquake, and due to this earthquake, what happened in the Pacific Ocean, the huge amount of water displaced in the Pacific Ocean, and due to that there induced a chances of tsunami in the Pacific Ocean and in the South China Sea. So that's why tsunami is again in the news in 2025. So tsunami is a important topic for this year. Now see, we have done with the geographical phenomena of the tsunami, we have done with the causes of the tsunami, we have done with the data and the distribution of tsunami. Now came what are the impact. So for the impact, I told you in my previous video that how you will generate point on impact. So for impact, what you have to think about the human angle, social angle, economic angle, environment angle, and the governance angle. So what happen in human or social impact? There is loss of life, there is mass casualties, so there is displacement also. So these are the human impact. Then talk about the economic impact. What happened due to tsunami? What happened? There is destruction of critical infrastructure, there is loss of property, there is loss of tourism, there is loss of fisheries, high reconstruction costs. So these are the losses, these are the impact of in the economic. Now the environmental impact. So what happened due to these tsunami waves? So due to this tsunami waves, biodiversity loss is there. So coral reef, destruction of coral reef, mangroves, wetlands. So there is loss of coastal ecosystem. There is marine life affected. There is salinization of water and groundwater, because what happened due to this, the salt water came in freshwater aquifer. So there is inundation of salt water in the island or in a coastal area. Then there is a governance angle, political or administrative impact, or you can write about the governance impact. So there is a governance challenges, rescue, relief, rehabilitation, strained government machinery. So these you have to write in your impact part. So think about this line. First, there should be human impact, then there is social impact, there is economic impact, there is environmental impact, and there is governance impact. Now, what are the mitigation strategy? So, for mitigation strategy, in our previous video, we'll talk about, so we had talked about how to generate NDMA guidelines and any mitigation strategy. If the question came on mitigation strategy, if the question came on measures, if the question came on solutions, if the question came on NDMA guidelines, then how to generate point. So, what you keep in your mind, first that NDMA 6 measures. So NDMA 6 measures. What was that measure? One, they should, first you will understand risk. How will you understand the risk of any disaster? First, there should be hazard mapping or zoning. There should be vulnerability assessment. There should be early warning system. There should be risk reduction data collection and management. There should be dissemination of information. So all these points you can write for any disaster while understanding risk of any disaster. So first point is understanding risk. Then what is the second point? So second point is inter-agency coordination. So in this part you will think about the regulation and enforcement. You will think about the disaster governance, and then the responsibility matrix. So all that you will write in second point, that is inter-agency coordination. Then the third is the disaster risk reduction. Here you will divide this into structural and non-structural measures. So in the structural part you will think about the critical infrastructure, that what critical infrastructure will be there to reduce that disaster or to mitigate the impact of that disaster. So we will write about the critical infrastructure. Then in the non-structure measure you will write about the rules, you will write about the regulations. You will write about the regulations, rules, policy making, mitigation strategies, or policy revision also. Policy revisions. So all that came in the non-structural part. Then the fourth point is, you will think about the capacity building. So for the capacity building, so there are common points. First, there should be training. Then there should be research and development. There should be community engagement. There should be youth engagement. There should be mock drills. There should be education and awareness, campaigns. So all these came in the capacity building part. So these I'll tell you the journal point which you can write in any disaster, any mitigation strategy, any NDMA guideline, or any solution about any disaster. Then the fifth point is climate change adaptation. So these are the NDMA measures, these 5, and on this line you will think and generate point in for every disaster. So climate change adaptation. So there should be integration of development and climate resilient infrastructure. Second point, you can write about the climate change adaptation assessment. So these are the point, or one general point also, international collaborations. So these are the international collaboration or coordination. So these are the important NDMA guidelines or mitigation strategy for any disaster. So here we'll talk about the mitigation strategy of tsunami. So all that point, first is early warning system, that came in understanding risk part, or you can also write the tsunami zoning, tsunami hazard zoning, or you can also write about the vulnerability assessment. Then the public awareness came in the capacity building point. Then the coordination, there is inter-agency coordination, there is disaster governance, then the evacuation plan. So there is evacuation plan came in the non-structural measures. Then the building codes, these also came in the non-structural measures. Community preparedness, this came in the capacity building point. And there is the research and monitoring, this also came in the capacity building point. And then the last point is international collaboration. So in this way you can write about the mitigation strategy or the NDMA guidelines. Then the next step is step taken so far for the tsunami mitigation. So first is India's tsunami early warning system. So this was established in 2007, operated by the INCOIS, Indian National Center for Ocean Information, and it is implemented by the NDMA. So what is this? It is a real-time network for seismic station, tide gauge, and 24/7 operational tsunami warning system. Then there is Sagarwani app developed by INCOIS. It is a software platform which uses state-of-art technology for dissemination of ocean-related information. So these you have to remember about every disaster, that what are the points so far taken by our government to mitigate that disaster. So first method, think about the NDMA measures, that 6 measure I told you, or Sendai 4 priorities. So think about the 6 NDMA measures and 4 Sendai priorities for generate point on mitigation strategy or NDMA guidelines. One first method is this. Second, you can also create your own mnemonics by this. So second, to generate point on any mitigation strategy of any disaster. So first method is to generate point in the line of NDMA measures or Sendai for priority. Second, create your own mnemonics by this. So I created my own mnemonic of tsunami. So from T, you have to remember any mitigation strategy, that is structural part, structural measures for tsunami mitigation is tsunami walls. Then there is S from shelter, U from utility of EWS or upgrade critical infrastructure, network collaboration, adaptation of new technology, mitigation strategy, I for information dissemination and strategic planning. So in this way also you can write, or even you can use this as a way forward also for make your answer more and more presentable. So use as a conclusion, use as a way forward in your answer. Then came our next disaster, that is heat wave. What is heat wave? So what is heat wave? So heat wave are the period of abnormal high temperature in a particular area. So suppose this is a area. So here the normal maximum temperature is 38 degrees Celsius. suppose, or 35 degrees Celsius. But due to some abnormality or due to some 2 to 5 consecutive days, what is happening? The temperatures, the average temperature of this area is 42 degrees Celsius from past 2 to 5 consecutive days, then we can say that there is a heat wave. So there are different definition given by different institution. The first definition is WMO definition, which defines that heat wave as 5 or more consecutive days during which the daily maximum temperature exceed the average maximum temperature by 5 degrees Celsius. So this is the definition of WMO. What it says, so in an area, if the temperature increase by 5 degrees Celsius for 5 to 6 consecutive days, then we can say that there is a heat wave. Then in India, heat wave condition are considered. So in India, according to IMD, what is happening in the plain area, if the temperature is 40 degrees Celsius or more, then we can say that there is a heat wave. In the hilly area, it is 30 degrees Celsius or more, and in the coastal area it is 37 degrees Celsius or more. If the temperature in the coastal area is 37 degrees Celsius or more, we can say that there is a heat wave in that area. So one more classification according to IMD. So there are two type of heat wave. IMD classify it to heat wave and severe heat wave. So when AMT, that is average maximum temperature, is equal to or more than 45 degrees Celsius, or AMT exceed NMT, means average maximum temperature exceed normal maximum temperature by 4.5 degrees Celsius, then we say that there is a heat wave. Or for the severe heat wave, when the average maximum temperature is equal to or more than the 47 degrees Celsius, or when average maximum temperature exceeds the normal maximum temperature by 6.5 degrees Celsius, then we can say that there is a severe heat wave in that area. So why? What is the geography behind this? Why heat wave is there? So what is happening? This is land. So why the warming of land is happening? So there is insolation. Insolation, the rays came from the sun which warm the land. First process is this. Second, what happened? Due to climate change, there is gases in the atmosphere which trap the long wave radiations. And which will came back to earth. So you know that these rays coming from the sun are the short wave radiation, or you can also call it the insolation, which warm the land. What happened at night? The earth release this long wave radiation in the atmosphere, but due to climate change, due to fossil fuel emission, there is a gases in the atmosphere which trap this long wave radiation, and this long wave radiation came back to the earth only, which will heat up the land. So second is this outgoing long wave radiation came back to earth. So these are the two main reasons why any piece of land is warming up. So what happened? There are reasons of or the causes of heat wave. So the first cause is high temperature. So if the temperature is high, if the insolation is increased by any reason, by the climate change or by the revolution of earth, so there is high temperature induce the chance of heat wave in any area. So first reason is there is a chance of heat wave due to high temperature. There is drought like situation. Then the second reason is less precipitation. So if the normal precipitation is less, so what happen? There is less precipitation, so there is drought like situation in that area. So due to that there can be a heat wave in the area. So why this less precipitation? So either climate change, El Nino impact, so all that will reduce the precipitation, and these also induce the chances for heat wave. What is the third reason? Third is urban heat island effect. So these can also be a one reason for heat wave. What is urban heat island impact? What happened due to urbanization? There is more urban construction. There is more urban emissions. There is more lack of urban governance because there is more population, so it will also impact the urban governance also. So due to urbanization, there is more construction, more number of people, so there is more deforestation is there. So due to that there is deforestation because more number of buildings should be built. So there is more concretization of land, which will make it concrete jungle. Then there is urban emission. So more number of people, more number of vehicle, more number of fossil fuel emission. There is AC emission, AC exhaust. So there is more urban emission, and due to that there is lack of governance in the urban area, and all these factors will induce the heat wave island effect in the urban area. So what happened due to this so much emission and due to this concretization, there is a urban dome like situation. So their creation a urban dome. What happened? There is low pressure system in the urban area due to high temperature, high emission, and on the upper atmosphere what is happening? There is high pressure system. So due to this low pressure system, this land is heated up and the air started rising. So hot air start rising because there is the expansion. So when this air start rising, this high pressure, due to this high pressure, what is happening? There is came back of this heat. It will not escape in the atmosphere. So it create a dome like situation. So all that heat, all that warm air came back to that area, which leads to heat wave. So this is the geography behind why heat wave is happening. So there is natural cause also and there is anthropogenic and the climate change also. So what are the causes? So see, here is the example of this heat dome. So what happened? Due to high temperature, due to this high temperature, what is happening? There creation a low pressure system on the land, and in the upper atmosphere there is high pressure system, and this high pressure system force the warm heat downward. So the warm heat would not escape in the atmosphere, and this will rise the temperature in that area, which will cause the heat wave. So what are the causes? First is high temperature. If there is a high temperature, then there is a chances of more heat wave. So high temperature by high insolation. Then the seasonal weather pattern. If there is less precipitation, if there is El Nino or Indian Ocean dipole, then the lack of rainfall, this can be also a cause. Then the urban heat island effect, their creation of urban dome in the urban area due to urban concretization, urban construction, urban emissions. Then the global climate change. So climate change also impact the heat wave in any area. Wind pattern also, change in wind pattern can influence the movement of air mass, potentially trapping warm air and causing prolonged period of extreme heat. Then the monsoonal delay or failure, the delay in the monsoon contribute to the heat wave. Then there is deforestation due to urbanization, due to pressure on the infrastructure of urban area, there is more deforestation, and land use changes also induce the chance for heat wave. So these are the major causes for the heat wave, or the geography behind the heat wave, geographical phenomena behind the heat wave. Then what are the impact of heat wave? So for the impact, what you have to think about: the human impact, the social impact, the environmental impact, the economic impact, and the governance impact. Same line you have to think point for heat waves. Then there is a one concept which is related to heat wave, that is marine heat wave. So what is marine heat wave? So when the temperature of seawater, so the seawater temperature exceed seasonally varying threshold for at least 5 consecutive days. If the seawater temperature increased for 5 consecutive days, then we can say that there is a marine heat wave in that piece of water. See, same as I told you for land, if there is water, see, this is the ocean. So this is the ocean. And this is the upper surface layer of ocean. So you know that there is a sea surface temperature. So on an average, sea surface temperature is 26 degrees Celsius. Why this sea surface temperature is there? Why this upper layer of ocean is heated up? So first is insolation. Same as land. Why land is heated? Due to insolation first. So the heating up of upper layer of ocean is due to the short wave radiation, that is known as insolation. Second is outgoing long wave radiations. So due to this gas in the atmosphere which trap the outgoing long wave radiation. So this will came back in the ocean, which will warm the upper layer of the ocean. This is ongoing increase in the ongoing long wave radiation that came back to the earth. Third in the ocean is this, due to this convection, see what is happening. If this is a ocean and this is a hot wind, so this is the upper layer of ocean and here is blowing hot wind. Hot wind. And what happened? There is a process of convection here. So what happened? Due to this hot air blowing above the sea surface or the upper surface of ocean, so these temperature which is contact with this air is start heated up, and this process is known as convection. So this water which came in the contact with this wind is started to heated up. So this process is known as convection, and due to convection there is evaporation. So there is evaporation of water, and when the water change into vapor, they release a latent heat of evaporation. So the third cause of this warming up of upper layer of ocean is latent heat of evaporation. So the third is latent heat of evaporation. So when this all three process or three causes is increases, then there is a marine heat wave situation. Suppose if there is a high temperature. So due to high temperature, what is happening? This upper surface of ocean is started heated more. So the width of this is increasing. Then if there is, due to climate change, if there is more number of molecule which trap the outgoing long wave radiation, then also the temperature of the sea surface temperature is rising. Then the third is, if there is due to climate change, then the third reason is due to climate change, there should be more evaporation, more heating, more evaporation, more heating. And due to this more heating, what is happening? There is more latent heat of evaporation, which will again increase the temperature of sea surface temperature. So the oceanic upper surface layer, the upper surface layer of ocean started heated up more. Due to this factor, one is high temperature, increase in the insolations. Second, if there is outgoing, if there is more outgoing, one second. Second is outgoing long wave radiation increases and came back to earth or came back to ocean. Third is climate change, and due to climate change there is more heat, and due to this more heat there is more evaporation, and due to that there is more latent heat of evaporation, which will increase the sea surface temperature. So these are the few reasons why there is marine heat wave, why there is abnormal heating of sea surface temperature for 5 consecutive days. Then we can say that there is marine heat wave. Now Now, what are the impact of both heat wave and the marine heat wave? First, we'll talk about the India's vulnerability towards the heat wave and towards the marine heat wave. So, if you see the India's vulnerability, so according to IMD data, there is increase in the frequency of heat wave, increase in the duration and the intensity of heat wave. This is due to the climate change and urbanization. Then you can also use this data from March to April 2022, hottest in 122 years. Also, you can use the 2024, the world hottest year by UN. So, these also you can use for the heat wave. For the marine heat wave, so the India's vulnerability according to IPCC, the marine heat wave have doubled from 1982 to 2018. So, according to IPCC report, then which shows that the marine heat wave is doubled from 1982 to 2018. You can also draw the map. You can also draw the India map for the heat wave. So recently the heat wave is happening in Delhi, Bangalore. So use that locations and highlight in the India's map. So use this India map, highlight the location where the current heat wave is there or in news. So you can give example of Delhi, Bangalore, Mumbai. So in this way you will make a India's map, and also you can use this graphical representation of number of deaths due to heat. So earlier there was 2566 deaths due to heat, but it increased to 6562 by 2015. So see the number of increase in the death due to heat. So this is the vulnerability of India towards the heat wave, and the marine heat wave. So now there is color coding for heat wave also. So there is a chance the question came on the color coding system of heat wave. So they are green, yellow. So green, yellow, orange and red color is used. For green, if there is a normal days, then the green alert is there. If there is a yellow alert, there is a heat alert. The condition for if there is a persistence increase in the temperature for consecutive 2 days, and if the heat waves are persist for 4 days, then there is a orange color. Then for the red, there is extreme alert, heat alert for the day. If the temperature persists, severe heat wave persists for consecutive 2 days. So this is the color coding system, color coding for the heat wave by NDMA. So impact, I told you, same impact, human impact, agriculture. See, due to this heat wave, what is impacting more is first the health. So the first is health. So due to this, there is heat strokes, dehydration. So the first impact is health. Second major impact is agriculture. So due to this high temperature or high heat, there is crop failure. Crop failure is there. So this will impact the agriculture the most and the health the most. So these are the two priority impact. Then the environment impact, there will be wildfire. It will induce the chances of wildfire because there is more heat, biodiversity loss, desertification or drying of rivers and lakes. economy, so there is a productivity loss. If there is a heat wave or if there is high temperature in an area, the working hour of the labor force or the workforce is decreased, and due to that there is productivity loss in our economy. Then the damage to infrastructure, so heat resistance infrastructure is required. So heat resistance infrastructure should be required for this, and there is loss of agriculture, tourism and fisheries. So these are the impact. So what are the impact of marine heat wave? So it will impact the marine biodiversity. So it will impact the most. First is coral bleaching and reef mortality. So due to this marine heat wave, what is impacting? There is coral bleaching and there is coral reef mortality. Then there is collapse of fishery. Marine ecosystem will harm the most. Collapse of fishery, and then the loss of kelp forest and sea grasses. Strengthening of tropical cyclones. See, for the tropical cyclones, so the first condition is there should be sea surface temperature. Sea surface temperature should be 26 degrees Celsius or more. But what is happening due to marine heat wave? So due to this marine heat wave, there is rise in the sea surface temperature, and this will increase the or strengthen the cyclone. It will increase the intensity of cyclone, it will increase the frequency of cyclone. So indirectly the marine heat wave will increase the sea surface temperature, which is essential condition for the formation of tropical cyclone, and due to that there is strengthening of tropical cyclone, which will induce the vulnerability on coastal area. So this will increase the vulnerability in the coastal area. Then the disruption of monsoon and weather pattern, and due to this marine heat wave, there is a disruption in the weather pattern also. So now came the mitigation strategy. So for the mitigation strategy, same you have to think in a two-way that I told you. Pause the video here, brainstorm and think your own points, what you have to write in the mitigation strategy. So do this exercise, pause the video here, try to brainstorm and think about your own points. So first you will what you will think. First is understand the risk of any disaster. So how you will understand the risk and how you will reduce that risk, that is early warning system. Then the interagency coordination, or you can write about another points also. There is vulnerability assessment, there is hazard zoning, there is dissemination of data and information, then there is a coordination. So you can write about the coordination, interagency coordination and the disaster governance. Then there should be structural measures. So for the heat wave, what should be the structural measure? So there is heat resilient infrastructure should be there. So there should be good urban planning. There should be cooling centers. So these all 2 or 3 points came in the structural part of the structural measures for the mitigation of heat wave or the marine heat wave. Then the building design, these building codes came in the non-structural measures. Then the public awareness came in the capacity building part. So these are the mitigation strategy. Pause here the video and generate this mnemonics for yourself, so that what you will write in the for the mitigation strategy for heat waves or the NDMA guidelines for heat wave. So brainstorm that what you will write in this, or you can use this as a way forward also. So here you can harness heat resilient infrastructure, here EWS, here adaptation of technology, here training, here awareness, here adaptation of research and development, here the vigilance and enforcement, here enhance community engagement. So in this way, it is easy in the examination hall to create your own points, to generate your own points. So these you can use as a way forward, as a mitigation strategy or NDMA guidelines. So what are the steps taken so far? You can use these. So there is NDMA guidelines, there is heat wave action plan by Gujarat, there is India's cooling action plan, and there is at the global level, there is global cooling pledge in COP28. So these you can write and learn. So these steps taken so far, you have to learn for each disaster. Now came the cyclone. So the next disaster is cyclone. What is cyclone? So the cyclone is intense low pressure system characterized by strong winds spiraling inwards and upwards with heavy rainfall. So let's do cyclone. What is cyclone in brief? So for cyclone, first there are two types of cyclone. So the cyclone came in tropic region. Tropic region is known as tropical cyclone, and there is temperate cyclone or extratropical cyclone. Extratropical cyclone which came in the temperate region. So you know, this is Earth, this is equator, this is Tropic of Cancer, this is Tropic of Capricorn. So here, if the cyclone came in this part, in the tropical region, then it is tropical cyclone. If the cyclone came in the temperate zone, it's known as extratropical cyclone or the temperate cyclone. See, the geographical formation of tropical cyclone is very much different from the extratropical cyclone. So both the formation process of both cyclone is different. So first we'll talk about the tropical cyclone. So tropical cyclone, for tropical cyclone to understand, first you will understand about high pressure system, low pressure system, what is Crowley's forces, sea surface temperature, what is sea surface temperature, vertical wind shear, what is vertical wind shear. So for tropical cyclone formation, there are 5 conditions which was there for the formation of tropical cyclone. First condition is there should be sea surface temperature is 26 degrees Celsius or more. This is the first condition for the tropical cyclone. So what is sea surface temperature? So sea surface temperature, if this is the ocean and this is the upper layer of ocean, so the surface temperature of the ocean, this layer temperature, the sea surface temperature is, this is the sea surface temperature. The temperature of the upper layer of ocean is known as the sea surface temperature. So for the formation of tropical cyclone, there is sea surface temperature is 26 degrees Celsius or more. First condition is this. Then you know. So second condition is Crowley's forces. So this Crowley's forces is due to rotation of Earth. So what happened due to this spiraling of air is due to this Crowley's force. So what happened if this is a Earth, suppose this is a Earth and this is the equator. So due to this rotation of Earth, so you know that Earth is rotating on its own axis, rotation of Earth, what is happening if any air came, so this is polar region and this is also polar region. So at the equator, due to high insolation, so you know that the maximum rays came from the sun is where? At the equator. So what happened? Due to this maximum insolation, there is at the equator there is low pressure zone or a low pressure system, and here the insolation is less, and due to that there is a high pressure system. So wind moved from high pressure to low pressure. So the wind moved from the high pressure to the low pressure system. Now when in the northern hemisphere, so this is the northern hemisphere, when this wind moved towards the equator, the wind moved from the high pressure towards the low pressure. So due to this Crowley's forces, this will deflected in the right side. So in the northern hemisphere, the wind will deflect towards the right side, and in the southern hemisphere, this is high pressure system here. So when the wind moves towards the low pressure system from the high pressure system, it will deflect towards the left. So it will deflect towards the left. So in the northern hemisphere, the wind will deflect towards the right, and in the southern hemisphere, it will deflect towards the left. And due to that deflection, due to this Crowley's forces, in the northern hemisphere, the tropical cyclone is anti-clockwise in direction, and in the southern hemisphere, the tropical cyclone is clockwise in direction. So these direction, anti-clockwise or clockwise or tropical cyclone, is due to the Crowley's forces, because due to these Crowley's forces, when the wind start moving towards the low pressure system from the high pressure system, it deflect towards the right in the northern hemisphere and it deflect towards the left in the southern hemisphere. So this is the concept of Crowley's forces. Now the third part is, so first we have done with the sea surface temperature, second there should be Crowley's forces. Then the third is high pressure and low pressure system. For the formation of tropical cyclone, there is precondition that there exists a low pressure system. So this is the precondition for the tropical cyclone, that there should be exist a low pressure system. So what is this high pressure and low pressure system? See what is happening. This is land. So what is happening? Due to high temperature or high insolation, so this land is started heating up. So it is heated up, and due to this warm land, what is happening? the air start rising. So as you know, as the temperature rise, so air expand. So the particle of air expanded as the temperature rise. So it started rising up. So the warm air start rising up. What happened when this air started rising up? There is a creation of void. So there is a creation of void or a vacuum. So there is a creation of void or a vacuum. To fill this void or a vacuum, what happened? The surrounding air suddenly rushed to fill this void or a vacuum. So what happened? There is a convergence of surrounding wind at the low pressure system. So to fill this void or to fill this vacuum, the air from the surrounding suddenly rushed towards this low pressure system and fill the void. So what happened? Due to high insolation, due to high temperature, high insolation, so at the equator, what is happening? At the equator, there is more amount of insolation came from earth. There is high temperature. Due to that, what is happening? There creation a low pressure system. So due to this, at the low pressure system, what is happening? Air start rising and there create a vacuum or a void. To fill this vacuum, there is rush of surrounding air to fill the void at the low pressure system. So if this is the low pressure system, so here what is happening? The convergence is happening because the surrounding air rush to fill that void that is created due to low pressure system. So here what is happening at the low pressure? There is convergence. So convergence is happening at the low pressure system. Now came the high pressure system. So what is high pressure system? So here is the low pressure system. So what happens? Air starts rising and here what is happening? The surrounded air will fill the gap. Now what is happening? As the air rise, so as you know, as the altitude increase, the temperature drop. So as the altitude increase, what is happening? The temperature reduce, the temperature decrease, and due to this temperature drop, what is happening? Contraction is there. So this you know, when the temperature rise, the particle expand, and when the temperature down or drop, the particle contract. So there is a contraction of air particles. So the air start cooling down. So here what is happening? Air start cool down. So cooling of air, and due to this cooling of air, what is happening? There is formation of clouds. So here condensation is there. So condensation is happening. So as the air rise above in the atmosphere, so it is started dense. So the air here is more denser, more heavier. So in the upper atmosphere, what is happening? The air is more denser and heavier, and when this air is too denser or heavier, it will sink. So it will sink towards the earth's surface and here create a high pressure system. So at the upper atmosphere, there is high pressure system. What is happening? Due to this denser air, there is a divergence. So the air is started to fall and this is known as the divergence. So at the high temperature, what is happening? The divergence is happening, and at the low pressure, there is a convergence is happening. So hope this clear what is high pressure system and what is low pressure system. Now what is happening in the tropical cyclone? So first condition is met, that is sea surface temperature, second is Crowley's forces, and third is there should be presence of low pressure system. And the fourth is there should be low vertical wind shear. So what is wind shear here? Suppose this is a surface and this is a troposphere or an atmosphere. So the speed, the intensity and the speed of wind at the surface and the intensity and the speed of wind in the upper atmosphere. So the difference between these two, the intensity and speed of wind at the surface and the intensity and speed of the wind at the troposphere or the upper atmosphere is known as the wind shear. So the difference in the speed and the intensity. So wind vertical wind shear. So vertical wind shear is the difference between the speed and intensity of the wind at the surface level and at the upper atmosphere. So for the tropical cyclone, the condition is there should be low vertical wind shear. So there should be low vertical wind shear. So the difference between the intensity and the speed of the wind here and here should be less. Why less? If the difference is high, suppose if the difference is high, if the speed of the wind here and here is different and the difference is too high, suppose the wind here is slow and the wind here is fast. So what happens when there is condensation? So if there is formation of cloud here, due to this high speed of wind in the upper atmosphere, these clouds are vanished from here. So these cloud came here. So there is no formation of tropical cyclone. When there is less difference, so see the wind speed here is same as the wind speed here, or there is less difference between the speed of both, then there is then the formation of cloud is here and the cloud is not vanished by this wind. So there is a low difference, low vertical wind shear for the for the formation of tropical cyclone. So these are the four conditions should be there for the formation of tropical cyclone. So this is the, suppose this is the ocean and this is a so here what is happening, this is the warm piece of ocean. So the surface of ocean is heated up due to high insolation or high temperature. So what is here? Here the air start rising and here creation of low pressure system. So here what is happening, due to air rise, what is happening, the surrounded air will fill this void. So here the sea surface temperature is 26 degrees Celsius, first condition met. Then second is there should be low pressure system and there should be convergence in the surface of temperature at the low pressure system. There shall be a convergence. Now what happens, as the temperature drops, as we move, one second. So as the air moves towards the upper atmosphere, so it start cooling down because of temperature drop. So here what happened, the air start cooling down and there is a formation of cloud. There is a formation of cloud. See, when the water vapor, so here is what is happening, there is condensation is happening. So the here is the air, so here is the condensation happening, there is a formation of clouds, and due to this condensation, what is happening, they release a latent heat of condensation. So they release a latent heat of condensation. So when this latent heat of condensation, what it did, it further uplift the surrounded air. So this heat is used for the upliftment of the surrounding air and make a more bigger cloud, which is known as the thunderstorm cloud or the cumulonimbus cloud. So either thunderstorm cloud or a cumulonimbus cloud. So what happened? The width of this cloud is increasing due to this latent heat of condensation, and when the saturation point of this cloud is breached, what is happening? There is rainfall, there is sink of this air. So this low pressure system or the center of cyclone is known as the eye of cyclone, and here this is the eye wall of the cyclone. So this is eye wall of cyclone. So here the low pressure system. So here the low pressure system and here the high pressure system. So what happening here is, more when the more heat is there, more essential fuel is there, when the sea surface temperature is more, so what is happening, there is more amount of heat is there, more amount of air is there, hot air is there, and there is a accumulation of cold air. So here the accumulation of cold air and it suddenly subside here. So it suddenly subside in the eye. So eye is a calm condition. So here is the calm and cool condition. So this is the formation of tropical cyclone. So tropical cyclone, see here is the, so this is the low pressure system, this is the high pressure system. At the low pressure system there is convergence and at the high pressure system there is divergence. So see what is happening. So here this piece of ocean, so this piece of ocean is started heating up and there creation of low pressure system, and due to that this hot air start rising. So the huge amount of moisture, this hot air contain a huge amount of moisture and it start rising. And what happened? Due to there is creation of a void, there is creation of a vacuum which was filled by the surrounding air. The surrounding air rushed towards the low pressure system to fill that void. So here is convergence is happening. So after that what is happening? So after there is a formation of, as the hot air move towards the atmosphere, it start cooling down and there the process is known as the condensation. The formation of cloud is there. So here the formation of these thunderstorm clouds, and due to condensation they release a lots of latent heat of condensation which will increase this width of the cloud, which is known as thunderstorm and cumulonimbus cloud. So when this air is so dense and heavy, when the saturation point is reached, this air sink towards the surface. And here what is happening? Here the accumulation of, so here the accumulation of warm air which cool down. So here the accumulation of warm air, as it moves towards the troposphere, it cools down, and due to this accumulation there is sudden subduction of this air in eye. So this low pressure system is known as the eye of the cyclone. This is the eye wall of the cyclone. So this is the whole system of tropical cyclone. So tropical cyclone have three stages. First stage is the initial stage. What happen in the initial stage? There is low pressure system and the hot air start rising. This is the initial stage of the cyclone. Second is the mature stage of cyclone. when there is well-defined eye, when there is well-defined eye wall is there, when there is a formation of cumulonimbus cloud in the upper troposphere, then we can say that the tropical cyclone is in mature stage. And third stage is the landfall of the cyclone. What is landfall of the cyclone? See what happened when this cyclone came in the contact with the coastal area or the land. See, this is the cyclone. When this came towards the coastal area or on land, what happened? The essential fuel, which is the warm water, the essential fuel for this cyclone is cut out. So the essential fuel is cut out. So the essential fuel, that is warm water, is no more in the tropical cyclone. So fuel cut down, and due to this fuel cut down, the landfall, the vanish of cyclone. So the cyclone is vanish as it moves towards the land, or it is on the land or the coastal area. So this third stage is known as the landfall of the cyclone. So first is initial stage, then the mature stage, and then the landfall of the cyclone. Now this is the causes. So this is the cyclone. What is the geographical phenomena of cyclone? So here you will write about the criteria. So these are the conditions for the tropical cyclone. There should be warm sea surface temperature. There should be high humidity in the lower and middle troposphere, Crowley's forces, low vertical wind shear, and the pre-existing low pressure distribution. Then if you see the vulnerability of India's vulnerability towards the cyclone. So more than 8,000 kilometers of coastline in the east and the west face the hazard of tropical cyclone and storm surges and heavy rainfall before and after the monsoon. So this is the India's vulnerability towards the tropical cyclone. You can also use this map for the tropical cyclone vulnerability in India. So this tropical cyclone, you know that the tropical cyclone are more in the Bay of Bengal as compared to Arabian Sea. But due to what is happening, due to climate change, the sea surface temperature is rising, and due to this sea surface temperature rise, the temperature of Arabian Sea is rising, and due to that there is now more number of cyclone in the Arabian Sea as well. So this coast is also more vulnerable now due to climate change and SST rise. So in this way you have to draw a map of India which show the very high prone, moderately prone or less prone area to cyclone. So these areas are more prone because the Bay of Bengal have more number of tropical cyclones. So this area is highly prone, then very highly prone, then this area is more highly prone, then the moderately prone. So this area yellow is the moderately prone area of cyclone, and then the less prone area of cyclone. So the more or less the coastal area is more vulnerable to cyclone and the tsunamis. Now what are the impact? Same impact you will think about the what is the human impact or social impact of cyclone. So loss of life, there is number of mass casualties, then there is the economic loss, there is loss of critical infrastructure, then loss of agriculture and fisheries, then the environmental, and due to this what is happening in the coastal area. See, coastal area is more vulnerable, there is a chances of coastal flooding, there is a chances of coastal erosion and destruction of biodiversity there, mangrove corals. Then the climate linkage also. See what is happening due to climate change, what is happening earlier is marine heat wave. So there is increase in the marine heat wave, there is increase in the sea surface temperature, and due to that there is more number of cyclone in the Arabian Sea as well. Then about the mitigation strategy, think on that line only, NDMA guidelines. So early warning system in the understanding risk part, evacuation plan, cyclone resistance infrastructure in the structural measures, then the mangrove conservation or You can use this also for, see, there is coordination and capacity building. Then the yield improved by climate resilient agriculture, community involvement, leverage technology, then overreach and awareness, then the network collaboration, and then the EWS. See, same point you have to write in every disaster mitigation strategy. The only difference is here, the structural measures. So the difference occur here is first structural measures. So the critical infrastructure should be different for each disaster according to that disaster. See, in the heat wave, you have to talk about the heat resilient infrastructure in the structural part, but in the cyclone you have to think about the climate resilient or flood mitigation, or more about that infrastructure which will reduce the cyclone impact on the coastal area. So the difference came here in the structural measures and the non-structural measure also. Non-structural measures also. So here you will think about the cyclone mitigation strategy, and in the heat wave or landslide you will think about the landslide or a heat wave mitigation strategy. So the only difference came here in the structural and non-structural measure. Other points are same for every disaster. So the coordination and capacity building you can use in every disaster mitigation strategy. Community involvement also there, leverage technology, use of research, use of technology in the climate mitigation and adaptation strategies. Outreach and awareness you can use in everywhere. Outreach and awareness, network collaboration or inter agency coordination, or the disaster governance. All these points you have to write in every disaster. And then the EWS, this is the more common point, every disaster mitigation strategy have it. Then the cloudburst. So the next disaster is cloudburst. What is cloudburst? See, cloudburst is not about bursting of cloud. It is sudden downpour of water in a small number of time over a small area. So this is the cloudburst. See, if this is the area, see, this is the small area. If there is sudden downpour of water, there is heavy rainfall in an area in a small number of time, or in a small area. So we can say that there is a cloudburst. So there is IMD definition of cloudburst, which says that if 10 mm of rainfall in 1 hour over 10 into 10 centimeter area. So either in mm or centimeter, if 10 centimeter rainfall in 1 hour over 10 into 10 centimeter square area, then we can say that this is the cloudburst. For the cloudburst, see, two conditions should be there. First, cloudburst is happen in mountain region, and second, there is monsoon. If there is monsoon, then there is a more chances of cloudburst. So what is the geography behind the cloudburst? See, so cloudburst, so 10 centimeter of rainfall or 100 mm of rainfall in 1 hour over 10 into 10 centimeter square area. See, if this is a land and here this is the mountain region. So cloudbursts are more happen in the mountain region. You know why? So first, this is the normal land. So normal condition is this due to high temperature. So the cloudbursts are more in the month of summer season, more in the summer season, because in the summer season there is high temperature on the land. So what is happening? See, this is the normal piece of land. So due to high temperature, what is happening? There creation a low pressure system. The air started rising, and as it rise above in the atmosphere, it start cool, and there creation of cloud, which is known as condensation. And due to that, there form a cumulonimbus cloud in the atmosphere. And what happened when the saturation point of this cloud breached, when the pressure is so high on this cloud, it what happened? It sudden precipitate. So precipitation is happen, and there is high rainfall in the area. So this is the normal condition in the land. But what is happening in the mountain region? So this is the mountain region. So what happened in the month of March, month of April? So what happened in this? The land is too warm, so the moisture laden air start rising, and monsoon is also there. So in the month of July also the monsoon is there, so there is monsoon or the moisture laden wind is there. So this what happened? This warm air when hit towards the mountain, so there is sudden upliftment of this air. So this sudden upliftment of air or warm air is known as the orographic lifting. So when this warm air, warm wind or moisture laden wind hit the slope of the mountain, there is a sudden upliftment, and this sudden upliftment is known as the orographic lifting. Due to this orographic lifting, there is sudden condensation. So this is the mountain, this is the moisture laden wind. So when this wind hit the mountain slope, there is sudden upliftment. It is known as the orographic lifting, and due to this lifting, there is sudden condensation. So there is a formation of cloud, and due to this sudden condensation, what is happening? There is latent heat of condensation, and this latent heat of condensation further uplift the surrounded air and make a more denser and a cumulonimbus cloud in the upper atmosphere. So what happened? This saturation point of this cloud is breached, and there is sudden downpour of water in the mountain region, and this is the cloudburst. When the sudden downpour of water in a small period of time in a small area, then we can say the cloudburst. So that's why the cloudburst is happening in mountain region. So cloudburst is happening in the first monsoon, and second in the mountain regions. So these two conditions, hope you will know now why the cloudburst is more in the Himalayan region, or like Uttarakhand, Jammu Kashmir. So recent Jammu Kashmir cloudburst is in news. So now you know why this is happening more in the mountain region, because of the orographic lifting, because of the sudden condensation, and because of the sudden precipitation. So cloudburst is a localized extreme weather event characterized by sudden and heavy rainfall in a short period of time over a short area. So this is the IMD definition. So if you see the cloudburst vulnerability in India, so in India, this Himalayan region, northeastern region, western Ghats, these are the most vulnerable for cloudburst, because these are the mountainous region. Cloudbursts do happen in the plain as well, but there is a greater probability than to occur in the mountain region, because at the plain area what is happening, there is a chance that there is a cloudburst, but there are more chances in the mountain region due to orographic lifting and due to sudden downpouring. So this is the cloudburst. This diagram you have to draw. What is happening? There is sudden upliftment. So there is sudden upliftment due to this mountainous slope, and there is formation of cumulonimbus cloud, and due to this condensation there release a latent heat of condensation. So here latent heat of condensation is there, which further uplift this cloud and make a thunderstorm cloud or a cumulonimbus cloud. And there is, when this saturation of this cloud is breached, there is heavy rainfall in a short period of time over a short area. So what is happening? There is convection because there is high temperature. Due to this, there is warm air updraft, there is more warm air rise, and due to that, what is happening, when this warm air came in the contact with the mountain slope, it sudden uplift, and which is known as orographic lifting. And then at the upper atmosphere, what is happening due to this sudden upliftment, there is atmosphere instability, and then there is cloud condensation. And when there is condensation, there is latent heat of condensation, which further uplift this cloud. And when this saturation point of this cloud is breached, there is sudden rainfall, which is known as cloudburst. So impact, same point. Think about the, if there in any area, if there is a cloud burst, what is the impact? So at the human level or the social impact is, there is loss of human, there is loss of life. At the economic level, there is loss of critical infrastructure, there is loss of property, there is loss of roads, loss of bridges. And at the social level, at the environmental level, what is happening, there is induced chances of floods. So here, due to cloudburst, there is induced chances of flood, landslide, there is biodiversity loss, and then the governance impact, there is lack of disaster governance. So all that impact came in this only. So this same point you have to write here. Then the mitigation strategy, see, if the cloudburst is there, think about that NDMA guidelines or NDMA measures and write that. First, safe settlement should be there, infiltration control, vigilance and reporting, regulating construction, drainage management and bioengineering. So here, this is the mitigation strategy. So here, at the structural, when you think about the structural measure, think about that critical infrastructure which will reduce the impact of cloudburst. So here, what will you think? You will think about the regulate construction. You should ban the construction in the hilly area. You should minimize the unscientific construction in the hilly area. There should be drainage management. So these came in the structural measure of cloudburst. So if there is drainage management is there, so there is effective rainwater drainage system is there, so that there is no condition for the cloudburst. Or you can use this also for cloudburst. So for mitigation strategy or measure, you can use this, or either as a way forward from see, there is a cloud monitoring. So for the understanding of this risk, there should be better forecasting system. Then the local hazard mapping also, there is upgrade infrastructure, there should be critical infrastructure for that. There is data collection, then build EWS, that is early warning system, utilize technology, rapid response system should be there. So there should be rapid response system if there is a cloudburst happen in that area, strengthen community engagement and timely evacuation there. So there should be timely evacuation. So these you can write in every disaster. Then came the forest fire. So what is forest fire? See, this forest fire became disaster when it is uncontrolled. So if there is forest fire, so it is not disaster. So you know the definition of disaster, I told you in my previous lecture. So the forest fire is not disaster when it is controlled, but when it is uncontrolled, so we can say this is a disaster. So forest fire is good for forest regeneration, but when it is uncontrolled, it became a disaster. So it impact the biodiversity, it impact the forest ecosystem, it impact the community ecosystem living in the forest. So forest fire is uncontrolled fire that can devastate large field and forest. For example, you can say the California forest fire. So this is the forest fire. So nothing much in forest fire. So what is the vulnerability of India towards the forest fire? That is more than 36% of country's forest cover. So out of total forest cover, 36% of country's forest cover consumes large field and area of land, often has been estimated to be prone to forest fire. So out of total forest cover, 36% of that forest cover is more prone to forest fire, or out of total forest cover, 76.4 million hectare in India is more prone to forest fire or the wildfire. So you can use the India map to show the India's vulnerability towards the forest fire. So these area in the red is extremely fire prone forest area, and this is the very highly prone forest fire. So this is the India's vulnerability towards the forest fire. What are the main causes for wildfire? So first, natural cause. Think about the natural cause why there is a forest fire or a wildfire. First is lightning. Second is high temperature. So these two are the natural causes for the forest fire. Then think about the anthropogenic cause. So there is human activity, there is deforestation, there is dry weather condition, there is invasive species also, because some species are more prone to fire. So more have flammable vegetation. So more this in like Latin chimera, or you can use the example of pirul. Pirul is a grass. It is a grass in the mountain region or in the Uttarakhand region. So this is pirul grasses which are more prone to the fire. So if there is sudden spark, so these fire are sudden. So the species like Lantana camara or pine increase fire risk due to their flammable nature or more prone to fire. So if there is a sudden spark in this species, there is increased chances of forest fire. So if these species are more in the forest, so the forest fire are uncontrollable in that area. Then the poor forest management also is the one cause. If there is poor management, then also there is the induced chances for forest fire. Then the national scheme or early warning system or the mitigation strategy for the forest fire. So if there is a forest fire, so what are the mitigation strategy for that? First, there should be good forest management system. So forest fire prevention and management scheme should be there. Then there should be early warning system. Then the large forest fire monitoring program is there of 2019. Then the burned area assessment and response. So these are the some schemes or national schemes or early warning system in our India for the elimination or mitigation of forest fire. So for the mitigation strategy, you can use this also. F for fire breaks. These came in the structural measure for forest fire. Then integration vegetation. Then research and development, education and awareness. Then the wildfire preparedness, improvement forest management, strategic coordination, enhanced community involvement. So these you can use as a mitigation strategy or a way forward for the forest fire mitigation. Then came the crowd management or crowd disaster. So crowd disaster is stampede. So recently many stampede is there, RCB stampede is there, New Delhi railway station stampede is there. So stampede is very much is news, or Mahakumbh also, there is a stampede in Mahakumbh. So what is stampede? So stampede is a crowd disaster. Sudden movement of large number of people, usually in panic, cause crushing, trampling and suffocation, leading to injuries and death. So what happens when there is large movement of people, large number of people are moving in a small area, there is a panic, so there is crushing of people, there is trampling of people, there is a condition of suffocation in that area. which lead to stampede. So this is the crowd disaster. So it is a man-made. So if you see, this stampede is a man-made disaster, and it is also notified by NDMA that it is a man-made disaster. Over 79% of stampede in India occur at the religious event. See, out of total stampede happen in India, 79% of stampede happen in the religious event, where terrain, infrastructure and crowd management are particularly challenging. So what happened if there is stampede? Think, so this is very general. Think about why this is happening. If there is overcrowding, if there is infrastructure lack, if there is lack of coordination, if there is lack of public control management. So these all are the reason for stampede. So stampede can be happen if there is overcrowding is there. So these create a situation of panic. If there is lack of infrastructure, अगर 10 लोगों का space है या 100 लोगों का space है तो उसमें 1000 लोग fit नहीं हो सकते. So this is the infrastructure lack. So there should be better infrastructure. So infrastructure, there should be better infrastructure. Then there should be lack of coordination is there. If there is a lack of coordination, interagency coordination, then also the stampede can be happen. Then the lack of public management, crowd management, the lack of strategy for the crowd management also lead to stampede. So here the one approach came, that is zero casualty approach. So when there is a crowd accumulation, or when there is any event happen, so what happen, the administration should follow the zero casualty approach. So there should be no casualty in that event. So these you can use in your answer. So you can use the graph, that is recent stampede happening and showing that area. So here the religious, so you can also use the here Delhi NCR, here the railway station stampede is happening. You can also use the Ram Janki temple religious in Hathras, UP. So so in the map show recent stampede. Then the causes, you know what is overcrowding. Overcrowding is one cause of stampede. Poor crowd management, inadequate infrastructure, or panic trigger if there is any rumor or any accident is there. So these can also be the cause of stampede. So what are the solution? You can use this. So think about the problem first. So what are the causes? There should be causes. One cause is crowd management. So there should be proper crowd management strategy. One cause is infrastructure. So there should be strategic infrastructure should be there. So there is coordination. So there is better coordination. So all that clear instruction should be there. Regulating movement should be there. Organized training. So train people, train community for crowd management. Watch for issue, develop infrastructure, cooperation. So there should be cooperation in the agencies. Obtain compliance, notify authorities. Then they take precaution, review procedure, optimize resources, or learn from the previous accidents or incident happen for crowd management, for crowd or stampede. Then came the biological and physical health emergency. So these can be natural or man-made. Natural, if there is sudden outbreak of any disease, then it can be natural. But it can be a man-made also if intentionally use of some virus or microorganism or toxin. So it can be, first it can be natural, and second if it can be man-made also if there is intentional use of this biological agent for the disaster, then it is biological it is man-made biological disaster. If there is natural outbreak of any epidemics or any disease, then it is normal cause of biological disaster. So you can give example of pandemic and epidemic, you can give example of COVID-19, you can also give example of Nipah virus, so influenza, flu. So these you can give example, this is not much. So what are the causes? So first, there should be outbreak of infectious diseases. If there is sudden outbreak of diseases spread beyond control, if any disease spread beyond control, then we can say that there is a biological disaster, or there is high mortality. If the number of if the number of mortality is very high, if the people number of deaths are very high due to that, then we can say that that is biological disaster. Then causes, it can be natural, it can be accidental, it can be intentionally also. So when the use of this biological agent is intentionally or used as a weapon, then this term is known as bioterrorism. When you use biological agent as a weapon, so for the biological warfare, it is known as bioterrorism. What are the impact? So same, think about that impact, human, social, environment. So for the human, if there is any biological disaster, like take an example of COVID-19. So what was the impact on health? So impact, there is mass illness, there is death, there is mental stress. But what is the impact on economy? So there is job losses is there, productivity losses is there, tourism loss is there. What is the society impact? That is panic, stigma, migration. What is the environmental impact? That is loss of livestock and wildlife. Then what is governance? Then strain on healthcare, risk of interest, risk of unrest. So these are the governance issue or governance impact due to this biological disaster. So now came the mitigation strategy of biological disaster. So think about the COVID or any like Nipah virus. So how you will mitigate the biological disaster? So first, there should be better infrastructure to deal with that disaster. So better healthcare system should be there. So first is this. Then second, you should develop the community engagement. You should train people. There should be build awareness in the people. Then improve surveillance. There should be better surveillance system. Then optimize vaccine research. So there should be vaccine research so that if any virus in the future came, we have vaccine to mitigate that. So legislative reform should be there. So we have the Epidemic Act or Epidemic Disease Act. So there are many lacunas in this Epidemic Disease Act. So we have to reform this. Then the organized training, global collaboration there, infrastructure should be there, health infrastructure mentioned here, health infrastructure should be good. Then there should be coordination between the agencies. Then advanced research should be there, mRNA vaccine, yeah, example mRNA vaccines. Then the leverage technology, so use of technology in the mitigation of biological disaster. So these are the mitigation strategies for biological disaster. So here we'll finish the disaster management part. So we did the disaster management both from the geography perspective and from the GS3 disaster management perspective. So hope this helped. Happy learning.